I'm Brett McCollum from the Department of Chemistry, and I am an Exim Scholar. To learn chemistry, you really have to use your imagination. A great example is if we think about this glass of water, many people would look at it and think, a refreshing drink. But as a chemist, you have to be able to visualize the billions upon billions of individual molecules that make up that water. So when we ask our students to learn chemistry, we're asking them to visualize something that they can't see with their eyes. We can't ask them to look at the molecule and understand its property. They have to be able to build a model in their mind to be able to understand the behavior of that system. Students have a lot of trouble with that. And so when I saw the iPad in 2010, I thought this is a great tool that's going to be able to help students to visualize molecular behavior in a 3D virtual environment. Computers have permitted that in the past, but the tablet, being able to be lightweight and portable, they can bring it into the classroom. We can use it in the room, they can use it on the bus, they can use it at home. I felt that this was going to really transform the experience that students might have in terms of visualizing molecular behavior. So I ran a study looking at how students perform when using the iPad as compared to more traditional technologies such as a static image they'd find in their textbook. And what we found after interviewing 100 students was that those who could use the virtual environment of the iPad in the Molecules app from Brad Larson, that they actually demonstrated statistically improved performance at transforming one molecular representation into another and constructing their own molecular representations. And so seeing that the iPad could improve student learning, I was curious how it was doing that. Particularly, I saw that students had been using the iPad in a different way than they were using the static images, that they were more engaged with the technology, and they also made a lot more gestures when working through a problem, that they'd be trying to solve which of these two representations is equivalent, and their hands would be moving even though they were quietly thinking. And so I asked myself, what is going on here, and how can I get to the bottom of the student learning experience? And that's really what my Nexen project was going to be about. So in my project, we were looking at the qualitatively different ways that students use different learning technologies. So how are students using the iPad? How are they using plastic models? And how are they using static images to try and solve chemical translation type of problems, to move from one representation to another representation. And one of the things that was really important was that we listened to the student voice, because we wanted to be able to hear how do they describe their problem-solving strategy, and whether or not we can see a relationship between their description and what we're observing them doing. Well, we found that those using the iPad developed the strategies they needed to successfully solve the problem. Those who were using paper-based images were very unsuccessful, the strategies they employed, and those using the plastic models were in between. But what was really unusual is we changed up the order that the students were using the three technologies. And those who used the paper first, we saw this development of skills as they moved through paper to plastic models to iPad. But for those who started with the iPad, in that first attempt, they developed a successful technique. And then when they used the paper, we expected that they, now understanding how to solve the problem, would employ that same technique just with a different resource. But that's not what happened. We saw instead that they reverted back, they regressed to these very low-level techniques that other students had been using when confronted with the paper originally. And so it begs the question, is the iPad supporting student learning, or is it helping students circumvent an important learning process and still get to the right answer? But because we listened to the student voice, we could see the difference there. We could hear the students as they described their problem-solving strategies. And we saw that when using the iPad, it wasn't that they didn't understand how to solve the problem and the iPad did it for them, but rather they could describe a successful technique that the iPad supported. And when they got to another technology, such as a printed image, they didn't know how to employ that same strategy with a different medium. So perhaps the real question we should be asking now is, how long does it take for students to practice that strategy so they can now employ it with other resources when the iPad's not available to them, rather than saying the iPad has circumvented the learning, because it hasn't. It supported learning. They just haven't had enough practice yet to embed that strategy in their toolbox for future learning. As we bring it into the classroom, we're finding new ways that it can support student learning, because that's our real goal here, isn't just to bring technology in because it's new and it's flashy and exciting, but rather we're trying to improve the student learning experience so that students can be more successful, so they can feel more comfortable with the learning environment, and particularly they can feel successful at being chemistry students, that they can begin to understand those 3 levels of representation that a chemist uses of the macroscopic, the submicroscopic, and the symbolic, and the connection between them. And so we're beginning to see different ways that we can use the iPad to support that learning, as well as other ways such as active learning and peer collaboration within the classroom. So in the fall, I'm going to be trying to teach a chemistry section now where we do a one-to-one iPad model, where all the students will have their own iPad rather than using a communal set where they share it. I'm looking at what differences will we see in the student learning when, one, they have 24-hour access to that technology so they can get more comfortable using some of the learning apps that we use in the classroom. But secondly, we're going to be trying to run the course without a commercial textbook. We're looking at the impact of student learning using portable tablet technology and an open education textbook. So I have collaborations with some peers in Colorado and Illinois, and we're looking at how we can use the resources that our groups are making to help students understand chemistry while reducing some of the barriers that we see with rising cost for textbooks.